So here are 3 spectrograms of the human voice speaking 3 different letters. The possibilities are C, S, and U. Those ones were specifically chosen because they're sort of an extreme case of filtering. So for one of these letters, we see the lows being cut out at certain points. In another letter, we see the highs being cut out quite a bit by the human mouth, the way they say the letter. So you have to look at the diagram and decide which one looks like letter C, which one looks like S, and which one looks like U. You can make your guess now. Okay, anybody want to make a guess? Yeah, go ahead. Very good. It is. So when we say the letter C, I'll record myself doing it on Audacity right now. C, U, S. Let's look at the spectrogram. Before we do, though, if you look at the letter C, the first one I said, you can see quite a difference in the waveform. It shows 2 distinct parts. First, there's a hiss. Then later, there's sort of a tone being made by the mouth. D. And it sounds just like a E almost. So we're looking for where there's a hiss and then a tone. C. Okay, let's check out the spectrogram now. Yeah, so the spectrogram shows that there is a high pass filter sort of happening with the mouth where I'm cutting out the lows somehow with my lips, but I'm letting that hiss sound come through. Then after that, we see the strong tones. The low frequencies are allowed to come through. C. So that's the letter C. Okay. Here we have the letter U. When we look at the waveform, you don't see any kind of hissing. You don't see that rapid oscillation. Because if you see rapid oscillation, that would be high frequencies. But we don't really see that here. So the high frequencies are being filtered out. And you see a lot of darkness up here, but some strong undertones there. Okay, then we'll move to the letter S. When you look at the waveform, you'll see 2 distinct parts to the letter S. First, I'm making the sound eh. And then after that, a hiss. S. So this is the hiss. And we should see that when we look at the spectrogram. So a lot of high frequency content in here. Lows are missing, except for the rumble of the HVAC in the room. And here's just a normal eh sound. So, okay, that's that. So, sample 1 was letter C. Sample 2 is letter U. And sample 3 is the letter S. Now, we have to get a little bit more precise and look at the beginning of the letter and the end of the letter. Try to determine which part of it represents a high-pass filter, meaning low frequencies are cut out. So you can look at the choices here. They're marked at the top, 1A, 1B, 2A, and so on. Basically talking about breaking it up into 2 distinct sections. So where do you see high pass happening? Yeah. So 1A and 3B is very distinct. So high pass is a term given to like when white noise is filtered such that the lows are removed. So this right here, this would actually be a low pass because you have frequency content in the low range. We don't see anything in the high range, no frequencies present at all. So that's high pass. I'll say similar to high pass filter of white noise. And then also this region right here, also similar to high pass. You could compare it to the drawing above. Which one shows high pass? A, B, or C? Yeah, this is like a high pass filter on white noise. Okay, but oppositely, this would be an example of low pass where we have frequency content at the bottom and the highs are filtered out because it's black up there. So now we're going to look for, similar to a low pass filter, which regions of the letters show low pass where the highs have been removed. Maybe you could pick the most extreme example. Yeah, 2B is the most extreme example where we have a ton of low frequency content but no high frequency content. So this is similar to a low pass filter acting on white noise. So of all the frequencies the mouth could have made, for whatever reason, here it's making low frequency sounds. That's the U. Yeah, you could argue that, here is pretty dark above. So you could argue that 1B is like a low pass filter, and also perhaps 3A, perhaps 2A.